You are listening to the IoT For All Media Network.
Hello, everyone, and welcome to another episode of the IoT For All podcast on the IoT For All Media Network. I'm your host, Ryan Chacon, one of the co-creators of IoT For All. Now, before we jump into this episode, please don't forget to subscribe on your favorite podcast platform or join our newsletter at iotforall.com/newsletter to catch all the newest episodes as soon as they come out. But before we get started, does your business waste hours searching for assets like equipment or vehicles and pay full-time employees just to manually enter location and status data? You can get real-time location and status updates for assets indoors and outdoors at the lowest cost possible with Leverage's end-to-end IoT solutions. To learn more, go to iotchangeseverything.com. That's iotchangeseverything.com. So without further ado, please enjoy this episode of the IoT For All podcast. Welcome, Eric, to the IoT For All show. How's your week going so far?
Going well. Thank you. Good to be here.
Yeah, it's great to have you. So let's start this off by having you give a quick introduction about yourself to our audience. Any background information, anything exciting about, your past history in the space that would be relevant for our audience?
Sure. I guess I'm most often known as serving as AI authority in the last year of the Obama administration. I worked with the Science Advisory Group, which I'm excited to know is now elevated to a cabinet level position under the Biden administration. Is an exciting place to be then, and I'm sure it's an exciting place to be now. I am fortunate to have spent my entire career, 20 plus years, in various capacities around what is AI. As a venture capitalist on Sand Hill Road for a time, I've started several companies. And I, in addition to working in Washington, started as a researcher. I've been at University of Washington, Seattle, at Stanford University, and then at Carnegie Mellon University, where I was faculty after getting my PhD in computer science. So I've seen this from a lot of different perspectives over many years, and that's the perspective I bring.
That's awesome. That's very exciting stuff. We don't have too many people that have the connection to the government, an experience in the government like you do. Can you tell me a little bit more about that? Kind of what the objective and the role there was, and kind of just the overall kind of purpose of kind of the position? Sure.
The Science Advisory Group is part of the Executive Office of the President, adjacent to the West Wing, which is really the Hollywood narrative. The very big building next to it has the National Security Council, the Domestic Policy Council. It has the Office of the First Lady, the Office of the Vice President, the Council of Economic Advisors, and then the Office of Personnel Management maybe comprises of the biggest in terms of square footage. This is all within the security perimeter. It also holds the Science Advisory Group. It was started under Nixon to provide science advice. On everything from space to water to issues in life sciences, and then a growing influence around information technology. So there was a chief technology officer as a new role established under the Obama administration, and then a chief data scientist as a new role started under the Obama administration. I was just happy to, for my period of time, be the authority on AI. There were other authorities in computer security, and mine was around AI, automation and software and in hardware. So it touched robotics. The particular job was speaking modestly on behalf of the president to coordinate the executive. So this is really a bipartisan issue. It's ostensibly a nonpartisan role where everyone would want our tax dollars to be spent effectively, and all of the million or so people that work across the U.S. government to coordinate on their initiatives in research, in deployment. From the State Department to defense, of course, to health and human services and transportation, how do they think about AI? How do they think about robotics? How do they think about their data collection and its use? Where do we need to do more research? Where are there security vulnerabilities and so forth? So the president has a view, and it's our job to communicate that out.
That sounds absolutely fascinating and probably a very exciting environment to be in. That's very cool. So tell me a little bit more about Conexus, your company now. Tell us obviously what you all do, the focus there, and then also I'd love to hear a little bit about background on the founding of the company, kind of the story behind it, and the problem or opportunity you saw in the market to obviously warrant the company being started? Sure.
Yeah, Conexus is one of the more rare stories you'll hear this year. It's because the discovery actually is in math. To hear that the MIT say it, Massachusetts Institute of Technology, the institute would say that this is the first ever spin out from their math department.
Wow.
That's right. That's quite a statement. So even though I spent time as a computer scientist, and even though I spent time in AI, this is sort of upstream from that. It's more fundamental from that. There's a blockage around fully taking advantage of AI, and that is in the collection and integration of data.
Okay.
Structured data, unstructured data, just all types of data. And this was born of that need.
Well, okay, gotcha. Very cool. So talk a little bit more to us about the role you all play in the market, use cases, anything that kind of brings us full circle to some real life examples of, solutions that you've been a part of developing, and how your technology and your offering kind of, plays a role in the market.
At an abstract level, you might think that a company with an infinite balance sheet to dream, and very smart people from any number of places might, in the abstract, create an optimal IT infrastructure. Right. This might be what some of the listeners can imagine, or what they go for, what their customers might think they go for. And that's just not how reality plays out, because the reality is companies are looking to implement what's needed for their business at any particular time. Nobody can really see years out. They don't know how their company is necessarily going to grow. So in one particular instance, we worked with a large ride sharing company. This ride sharing company has an effectively infinite balance sheet and some extremely smart people. And yet they do not have at all an idealized IT infrastructure. That IT infrastructure in their particular case grew up jurisdiction by jurisdiction. Anybody else can think about this by department or by customer need. This was by city. So this particular ride sharing company would look at the city of Los Angeles and want to say, well, I want to do a business case for the rates versus rider satisfaction, or the weather versus driver satisfaction, or whatever sort of business analysis that one's AI algorithm might engender.
Right.
But in order for them to do that, they could do the city of Los Angeles, and then they would have to do a statistical comparison to the city of San Diego. They couldn't do those two, the whole state of California, let alone all of North America or all of the world. This impaired their business decisions. It also slowed their business decisions. So they implemented our solution, looking really around the world. How does this get solved? How do we integrate these hundreds of databases all into one to make better business decisions that are faster, more accurate, and really represent the responsiveness that we seek? And the answer was that they had to look more fundamentally than the computer science solution. So some of your listeners might be familiar with RDF and OWL. Those were solutions in the early 2000s to try to deal with this data deluge that we often read about in the press. The doubling of data every very shockingly short period of time. That continues, but it's been a failure because it really doesn't scale. It fails to keep up with the size of databases today. So this company looked around the world. They found us. And to have them tell it, we were the only solution available to have them integrate the totality of their data, because we're just fortunate to be recognized as the leaders in enterprise software, taking advantage of this particular discovery in math.
Fantastic. Yeah, that's, the use case, along with the story of coming out of MIT as the first company from the math side is absolutely fascinating. I don't think, unless I was having a conversation with you today, I would have known that, or even a guess that otherwise. You just would assume with this, the high profile MIT that other businesses have been built out of the math side. So that's really exciting, and congrats on all the success you guys have had so far.
Thanks.
So I wanted to kind of bring this a little more high level here for a second, and see if you could talk to our audience a bit about an AI system in general, kind of what an AI system, what it means to have an AI system, how an AI system works, just less technical and more kind of on the layman terms of just kind of what that is when people hear about it, and why it's important.
I think it's really terrific to delve into that question. Thanks for asking it. It's important that all of us get involved in this conversation around AI and not just think it's for people like me that grew up in a basement in front of computers. It's for everybody. Right. And the term is a funny one because it's begun to emerge that people think it doesn't really exist. There is no really artificial intelligence, and I find that to be confusing. The what we used to call generalized AI versus specialized AI. But these sort of distinctions, they really don't matter to the 99% of us that are not AI researchers day to day.
Sure.
I find that these definitions are more helpful if we just look at what's useful for somebody's day-to-day existence. And I like to look at the very beginning. So how is the data collected? How is it sensed? This show is about Internet of Things. This is data from those Internet of Things. My dishwasher somehow is connected to the internet for some reason. So it collects data. It's for maintenance. And that's a collection of data from different sources. It could be the LiDAR on top of the car. It could be the air quality in the rooms we're in. That's the collection of data, sensing data. And then that data is transferred to thinking, planning, cognition, we might say. That's where traditional AI would live. And if we really wanted to get pedantic, we could say that the popular term of machine learning is a subset of AI, and the popular term of deep learning is a subset of machine learning. So there are non-machine learning AIs, but that is not useful for the 99% of us that are not AI researchers. And we can expand that further. We have the sensing, we have the planning, but we then have to act. We have to do something with the data. So if my automated car collects data from the LiDAR, then processes that in the totality of its system inside the car, it then has to decide if what is in front of it is a shadow, is a crosswalk, is a person, and what the actions are. If it should slow down, if it should wait until it collects more information, or if it should just continue at the same speed for whatever reason. That's an action. So you have sense, plan, act. And then what's unique about AI, so it's not just the thermometer from the 1970s, it learns from the experience. So it'll start to learn. Yeah. Now, AI systems don't spontaneously learn. This is almost a misnomer or a misunderstanding about what the learning is. My automated car is not going to go down a street at an intersection, see that crosswalk for the 1000th time, and suddenly start spouting Mandarin. It doesn't learn that way, right? It's funny when I say it that way. It's so obvious, but people get this misinterpreted. It becomes a better driver on that intersection. Now, the learnings might be then fed back into the manufacturer, and the manufacturer could use that as learning to increase the efficiency of the algorithms in general. But the car itself is only going to learn that intersection. So sense, plan, act, learn from the experience. That, I think, is a useful definition for nearly all of your listeners.
That's fantastic. And when it comes to all the different components and pieces that make up an AI system, which ones would you say are the most important and kind of that really drive the success of an AI system when it's deployed?
I was in computational linguistics for a number of years, and I found that there was a certain dynamic that plays out more broadly in information technology in general. And it's this idea of waves of tech and then waves of application of tech. So we would learn the new machine learning techniques, and then we'd apply them to language, and we get all really excited and have some breakthroughs. And then we'd reach the limit of that and then have to go back to researching language again, semantics, semiotics, syntax, what have you. And then a new technology wave would come along and we would apply that again. I find the same with AI and maybe even enterprise software, where if you look at the system that is AI that we just distinguished, sense, plan, act, we might say that many of the technologies that we now live with deep in the infrastructure of our world, products from companies like Oracle and Microsoft and even Salesforce to some extent, those were really innovative products 20 years ago, 30 years ago, and in the case of Oracle, 40 years ago, right? But the innovation has been felt instead on the consumer side, where that what used to be the laggard. But now we have some fantastic consumer-oriented technology devices. But now enterprise software is really lagging. So I might say that whole system is just up for some new developments that are terribly exciting. In particular, as we started this conversation, look before the learning algorithm. So there's a lot of seemingly magical items coming out of deep learning. In the case of DeepMind's protein unfolding, they deserve all the praise that you see in the popular press. One of the companies I sit on the board of, Petuum, they have a fantastic suite of AI products that can democratize its application across industries. But for many venture capitalists, they're going to be disappointed with the returns in that domain because the bottleneck is upstream from that.
Okay.
There's a lot of data collected that's not used. Dark data.
Interesting.
There's a lot of data that exists in these databases that's not adequately brought together. There's the refactoring of databases, keeping the semantics while the structure changes is where careers go to die. The years are invested, hundreds of millions of dollars. It's really it's where the calcification of old industries begins to show up. And that's what I'd say is an exciting place to look. This is deep in the plumbing of our world and how it operates. It impairs some of our logistics systems. And maybe I can give a story about that. During the early stages of the COVID crisis, we were working with a logistics company. Okay. You read in the news recently about that large container ship that went, it's going to say sideways, kind of diagonal in the Suez Canal. Well, those ships you read about have thousands or even tens of thousands of containers on them. And there are thousands of these ships around the world. And it was hard for us to imagine that when one of our clients, or rather one of our clients' clients, each one of which has tens of thousands of employees and thousands of ships with those tens of thousands of containers, they don't know immediately where their stuff is. They want to ask a business question. Where's my stuff? And so in the early days of the COVID crisis, where's the personal protective equipment? Where's my PPP? And should it go to San Diego or Santiago? But I don't know even where it is. That business question ideally would be answered, again, ideally, in a matter of hours. Instead, it takes days. That's an expensive question to ask, in other words. Right. So we help solve that problem, integrating the databases to make those business decisions faster, cheaper, and allow the business to become more flexible. That's another example of just bringing data together. That's an exciting place to look.
Yeah. So let me ask then from a listener standpoint, what type of company, individual, organization, industry do you all kind of focus on, if any? And at the same time, who out there listening should makes the most sense to kind of reach out and engage you if they're interested in kind of just getting a better sense of the work you do and how your offering could work with what they're doing? Like, do they need to be in a certain stage of development? Do they need to be focused on a certain kind of problem? How does that usually handled on your end, like that typical customer engagement, and just any advice out there for people that are very intrigued, obviously, by this conversation and want to kind of connect in that way?
Well, for us as a firm, we generally work with larger firms with complex data infrastructure. that the ones that have thousands of tables, tens of thousands of tables. Sometimes it's measured in size of the database, petabytes of data, but it's really the complexity of the data set. You might say it's physically heterogeneous, but the data models are homogeneous. That's a terrific scenario in which we can provide the quickest value. Specifically in Microsoft SQL environments, that's a good place to be looking to have the quickest return. I can offer in general the guidance for people around the foundational technology for your listeners to just listen for in other environments, which is the discovery of category theory. So categorical mathematics is the branch of mathematics that powers what we do. We're not the only company that'll be doing this. We're not the only company today that does it. We're just the leaders in enterprise software taking advantage of that. But category theory as a branch of math is the math of the 21st century. That's where I suggest people look in general for themselves, for their companies, for their children. You might say the more math, the better. But in 10 or 20 years, calculus, geometry, trigonometry, that's going to look a little bit like speaking Latin to each other. Gotcha.
Okay. Interesting. Now, I want to take a kind of a shift topics here for a second and talk a little bit more about when you all were coming to market and kind of forming the company. What were some of the biggest challenges that you all saw in kind of promoting and educating the market on the value of what it is that you're doing? Are there anything kind of that stands out to you that was a relatively noticeable challenge and kind of how you guys overcame that?
Yeah, the problem for us is we compete against not doing, and we compete against manual. Okay. So if you look at the revenue of some large consulting firms, and I'm not just talking about Deloitte, Accenture, McKinsey, what have you, but you look at Tata, Wipro, Tibco, those companies have grown their revenue right in line with the rate of data growth. Those companies exist because of this a problem in data interoperability, because that process is horribly manual, using tools like from Informatica or Ab Initio, which themselves are good companies, but it's a terribly manual process that seeks to be automated. But if a company has grown up with this business process of just putting a decision through even a manual operations, shifting out of that can be not worth the effort, not worth the risk. Sure. So that was a challenge. Even the canonical 10 times benefit or even 100 times benefit can be a misleading metric if what you're competing against is a given business process. And you can know this intellectually. I knew this intellectually. I've taught this, for goodness sake. But coming upon it firsthand is it's funny to see in action, where just the nature of large organizations is no one person is in a position to disrupt the business process. No one wants to change their workflow. That's a lesson to learn.
100%. I understand that completely. Yeah. Absolutely. That's great. That's great. I wanted, as we're kind of talking about those challenges, I guess with, obviously your extensive experience and knowledge of the market for many years, what are you seeing as some of the biggest trends in the market right now as it relates to AI and even IoT to some matter?
IoT, I think, is being misinterpreted in its impact. It's not about collecting more data by itself that is the value. It's the relationships between the data. So it's not, we worked with this utility company in Europe that had windmills. I came to find out there are 5 large windmill companies in the world. There are more, but there's 5 companies comprise 90+% of the market for windmills. Now, those windmills for you and I are interesting only to the extent that they supply power. Right? I mean, they're green power. That's fine, but we don't care about the nuances, right? But there are sensors on those windmills that will detect the temperature. It's 4 degrees centigrade. These are in Europe. It's 40 knot winds expected. That's data. Right? So that's data. We're sensing, planning, acting, learning from the experience. So we're sensing the data, collecting the data. That's nice. But what's much, much more valuable and what's unique to a company, this is where every company is becoming a data company, is the unique knowledge that a company would acquire when it is 4 degrees Celsius and there was predicted to be 40 knot winds. Then something happens. Something could be, there's a chance of freezing. There is increased efficiency on the windmill. There is a shorter maintenance window. What happened? Whatever. That's knowledge.
Yes.
That's valuable. The data collection, much, much less valuable. It's the knowledge from the relationships of the data. The sharing of knowledge, that's the future. And then going one step further, it's the patterns in the relationships of the knowledge. Those are the people that are going to own the future.
That makes a lot of sense. I mean, we talk a lot on here about the ability for companies to collect data in ways that they have not been able to collect data before due to the advancements in technology as it relates to IoT. But it's interesting, your approach, which makes a ton of sense, which is the data collection is becoming a bit more trivial now. And it's actually what you do with that data, how you interpret the data, the decisions you make on that data, basically that knowledge like you're talking about is what dictates the value and the success of the entire process to collect the data. And that's a great way to kind of explain it, what you're saying, because it hasn't really been explained that way to our audience, I don't think, as of late.
Yeah, the models, the schemas, that's where every company is going to derive value. That I say that every company is an AI company because a lot of other things are just becoming commoditized. Whether you're a public utility or you're a mining company or sort of a shipping or logistics company, many of the physical goods are becoming commoditized. And like we're saying, the collection of that data can become commoditized. But the relationships, the knowledge, that's becoming the gold.
Gotcha. One question I would ask is, it's not really related, but it's just a term I hear often, and I'm not sure if our audience fully understands it because we don't cover it very much. But data lakes. Can you talk a little bit more about what data lakes are and kind of what their purpose is and kind of your overall just view of them?
Yeah, data lakes were trying to compensate for the failures of data warehouses. Now, a lot of these terms I don't like because just like we started off talking about AI, the terms themselves can have specific meanings, but it's the interpretations of the terms that really matter, right? So I will say in data lakes, what it's come to mean is magic. I'll bring all my data together in one place. There was an example earlier in the COVID crisis where C3.ai got a lot of press for creating a data lake about COVID information. But really what they did is they brought everything together essentially on one hard drive. It doesn't make your analysis necessarily any more useful or available. I guess I'll say that. It doesn't make it any more available because, when one is trying to do analysis, make better business decisions, all of your data needs to be integrated. There is no AI without integrated data. Okay. And I'll just say that again. There is no AI without integrated data. You have to have fully integrated data. If you have data that you collected, but it's just somehow sitting around, that's dark data, right? That's bad, right? So the data lake was an attempt to first collect all the data essentially in one big hard drive, one big lake, and then we'll worry about the integration later. We'll let the data scientists do their integration later. But that is the proverbial kicking the ball down the road to let the data scientists do the work. But the hard part isn't necessarily using these increasingly sophisticated off-the-shelf learning algorithms. It's actually collecting and integrating the data. That's the hard part. That's the manual part. That's the part that takes years. It takes a commitment from senior management. And unfortunately, today it takes the manual effort of many of these consulting firms costing tens of millions of dollars over long periods of time. So the data lake was an attempt off the to solve warehouses. It's becoming a little passe now. So Databricks introduces the concept of now data. What do they call it? Lake houses. So these little islands of integrated data within a data lake. But my favorite term is really data bog or data swamp because they're just a mess. It's just a mess of data. You really did nothing. You think you did something. You took actions, but you really made no progress. I guess that's a nice way of saying it.
So if I'm a listener or a company that has a lot of data, more of this dark data that they haven't really done anything with, what's the best first step on how to get that integrated and start really utilizing it the way you're kind of advising?
Yeah, I'll give a couple pieces of advice around this. And the more general is that you need to begin to develop the discipline as a person and as an organization to think more specifically about where your data lives, certainly where it comes from, and then where it's going to go. So any idea you have, and it came from my experience in government, but it applies to any large organizations. Any idea you have has to be grounded in your databases. This is funny for an AI guy to be saying this but this is where the limitation is. Where is the data coming from? Where is it going to be stored? Where is it going to go to? You need to be thinking in very specific terms. If I thought of any public policy failures, but this also goes true for business failures, where those germinate is in databases not talking to each other. So you need to think very specifically, where does this data live? What formats does this data live in? How will we, over what period of time, integrate that data? And I can just give a story about how pernicious this problem is. So we're working with a large hospital chain in northeastern United States, a brand name hospital chain. This is one organization that has different definitions of diabetes. Okay. And you think, well, that sounds weird. I don't quite understand that. Diabetes just is. I can go on Wikipedia and it seems like a pretty consistent definition, right? But it's that they haven't thought as an organization formally about a way that they can agree on the definition. So one department may have their own uses for their data collection and have agreed, essentially saying diabetes, yes, no. Yeah, diabetes, do they have it? Okay. But another part of the same organization might instead say diabetes, how long ago? When did it start? And another part of the organization would be maybe from well-meaning people thinking, well, I'm not just going to say yes, no, or when did it start? I'm going to say diabetes, how bad and how are we treating it? Right. And that all can be in one column of data called diabetes. You can do the same thing by date start. This happens in every organization. Date start. What does that mean? Date start when I first detected it. Date start when I started treatment. Date start when the contract started or when the contact started. Date start. And if I want to bifurcate that table into something more meaningful, that's actually a very difficult process and can result in catastrophic failures. Mizuho Bank is a Japanese bank because of exactly this sort of problem, had all their ATMs go down for a day. All their client accounts go down for a day. That's a failure of production databases and generally around these database refactoring problems.
That makes a lot of sense. That's fantastic. Thanks for sharing those insights. Because I think a lot of people out there that are getting started on this journey are understanding the data collection part, but it's that next piece of understanding how to utilize the data and not just have their data sit dormant is something I think they could use a lot of kind of help and advice on. So I appreciate that. As we wrap up here, I have a couple last questions. One is, it's a comment that a lot of people that are new or just kind of hear about AI, see it in movies, see it on TV shows, kind of talk about as a future fear about AI replacing humans. And I'd love if you could just give your thoughts on that kind of topic and how you see that being either a correct or incorrect statement, and what you kind of see as the future for AI as it relates to interacting with humans.
I got this question every time I would meet a new congressman when I was in Washington, and there's a lot of different ways to address it. The idea is that AI is not going to be a utopia, and it's not going to be a dystopia. It's going to be somewhere in the middle, and the where in the middle is going to be up to us. The how in the middle is going to be in how we engage in this conversation. AI could be thought of as an augmentation. It could be thought of probably more generally as an automation. And its automation has replaced humans for as long as we've had tools, really. And we don't really shed a tear for the treasury bond traders that lost their jobs because of machine learning, right? We might be a little more empathetic to the telephone switchboard operators or the elevator operators. You remember we had manual elevator operators, before either of us were born, maybe before our parents were born. And those elevator operators came out, and those elevators became automated. People got concerned about elevators. And in order to entice people into the elevators, to make it seem safe, music was introduced to the elevators. That's what we got the term elevator music. Made it seem safe and welcoming. I'll be part of this automation. So automation can be scary. What's different today? What's changed? Why, besides the term artificial intelligence, is this something different? It's that digital technology by its very nature doesn't work. And then when it works infinitely well. It scales it just infinitely well. So it's in the abruptness of the change. When jobs were displaced before, the person at the telephone switchboard could live out their career, or in the bond market, maybe less so. But those careers continue to exist, just people wouldn't go into the job newly. What's different today is as soon as digital technology works, that career could be over in a year or two or less, whatever. My prediction for automated trucking, which is often what people talk about when you hear long haul trucking, is that job is actually going to get better before it gets worse. Because long haul trucking is actually an awful job. And even the people that do it know it because they're away from their families for a long time. But there are people working on pelotons of, not the firm, the Peloton of the bicycle or the Peloton of the trucking company, but the concept of pelotons from cycling, the pelotons of semi-trucks that can allow long-haul truck drivers to go for long distances and be back home quicker, to create more stable relationships and a more enjoyable life experience for themselves while they're long-haul truckers. That will happen, making the job better long before that job is eliminated. In other areas, I would say a couple of things. One is we can't tell. We don't know. I would challenge anybody in the year 2000 to have predicted not just the smartphone. People could have predicted in general what a smartphone would look like, but the implications of a smartphone to create a career called app developer, let alone everything that came after that. Nobody could have predicted app developer as a career path. It just didn't, unconceptualizable, we might say. And it's in that I introduce a new job. The new job is that of an ontologist. Now, this is not ontologist like the philosophy that we all it came about, nature of being and all that from school. But Amazon has now 12 ontologists, 12 professional ontologists, and they're going to hire 12 more in 2021. If you look at some life sciences company, go to Pfizer or Amgen, whatever, they're hiring ontologists. And ontologists capture the knowledge of the organization. They are professionals at figuring out how to capture knowledge. That is a new career that is emerging, and it pays quite well. But that's something none of us could have predicted even 5 years ago. And that's what I suggest is going to happen. What we can do is be responsive to this future. Don't try to predict it so much, but set up our lives to be responsive to what's coming down. You can't predict the next pandemic, but you can be responsive quickly. And that comes from integrating all your data so you can make better decisions more quickly.
That is a fantastic way to end this. Because I totally get where you're coming from. It makes a lot of sense. I think obviously there's a lot of fear for people who don't have enough information to really understand the value and the purpose of AI, and they just kind of assume that it's going to result in humans losing their jobs. Where, as you mentioned, if we really look back, a lot of this technology creates new jobs, things that we never would have expected until it happens. So So all your insights today have been fantastic. The passion you have for this topic is incredible. I think our audience is going to really like this episode. The last thing I wanted to do is just kind of last couple seconds here, just give an opportunity to kind of share if anybody out there is listening and wants to learn more about Conexus, learn more about what you all do, the offering, or potentially is looking to potentially engage in some kind of relationship. What's the best way they can go about doing that?
Info@conexus.com. It's Conexus. Okay. Nexus, Latin for join, conexus.com. And I'm Eric Daimler on all the usual places on the web.
Fantastic. We'll be sure to link that up when we get this out to our audience. Eric, thank you so much for your time. It's been a great conversation, and thanks again for being here.
It's been a good time, Ryan.
All right, everyone. Thanks again for joining us this week on the IoT For All podcast. I hope you enjoyed this episode. And if you did, please leave us a rating or review and be sure to subscribe to our podcast on whichever platform you're listening to us on. Also, if you have a guest you'd like to see on the show, please drop us a note at ryan@iotforall.com and we'll do everything we can to get them as a featured guest. Other than that, thanks again for listening and we'll see you next time.